Long before assembly lines exist, tractors begin here, where raw iron ore sleeps inside the earth, untouched and unrefined. These massive fragments of iron-rich rock are the purest starting point, containing the metal that will eventually become structural steel. Embedded within these towering walls, concentrated iron deposits formed over millions of years, waiting to be extracted for heavy industry. After controlled blasting, the earth releases millions of tons of raw ore, scattered across the ground in its most primitive state. This immense landscape supplies the essential metal for modern machinery, the natural starting point of every tractor's steel skeleton.
Extraction begins as colossal shovels bite into the rubble, lifting dozens of tons of raw iron ore in one motion.
Each load crashes into haul trucks built like moving fortresses, engineered to carry hundreds of tons of untouched ore. Loaded with raw material, the trucks begin their climb, transporting the iron ore from the depths toward industrial processing. Before entering the industrial chain, the ore is gathered in bulk stockyards, forming vast reserves ready for continuous supply.
From the mine, the raw ore is loaded onto heavy freight lines, beginning its journey toward the massive steelworks.
Inside the steelworks, the raw ore enters the first stage, feeding into massive hoppers that regulate continuous industrial flow.
Primary crushers reduce massive ore chunks into manageable sizes, breaking solid rock with relentless mechanical pressure for downstream processing.
High-capacity conveyors transport the crushed ore continuously, moving thousands of tons every hour deeper into the processing line.
Rotating screens separate the material by size, allowing only properly graded ore to continue while larger fragments are recirculated. Secondary crushers apply concentrated pressure, refining oversized fragments into consistent pieces required for efficient large-scale smelting. Vibrating feeders regulate the stream, distributing crushed ore evenly to maintain steady, uninterrupted flow throughout the steel plant. Powerful electromagnets extract iron-rich material from waste rock, isolating the valuable metal needed for high-strength industrial steel. Inside rotating mills, hardened steel balls pulverize the ore, grinding it into fine concentrate for efficient chemical refining. Flotation cells refine the concentrate further, separating impurities through chemical reactions that leave only high-grade iron material behind. Gravity separation inside massive thickeners removes excess water, concentrating the iron solids into dense material ready for thermal processing. High-pressure filters squeeze out remaining moisture, transforming the slurry into solid iron concentrate cakes, ready for high-temperature treatment. Rotary dryers apply intense heat, removing residual moisture and preparing the iron concentrate for efficient pellet formation. Pelletizing discs roll the fine concentrate into uniform spheres, creating consistent feedstock optimized for high-efficiency blast furnace smelting. Within massive induration furnaces, extreme temperatures harden the pellets, transforming soft concentrate into durable iron feed for smelting.
High-capacity cooling systems stabilize the hardened pellets, preparing them for the extreme conditions inside towering blast furnaces.
Measured precisely, iron pellets are combined with coke and flux, forming the balanced charge required for efficient blast furnace smelting. Layer by layer, raw materials are fed into the blast furnace, building the charge that will be transformed into molten iron. Superheated air is injected at extreme pressure, igniting the coke and driving the intense chemical reactions that melt iron. Within the furnace core, temperatures exceed 1500 degrees, reducing iron ore into liquid metal while impurities rise as slag.
The furnace is tapped, releasing a continuous river of molten iron that will soon become the structural steel of every tractor.
Molten iron is transferred into insulated ladle cars, preserving extreme heat while transporting the metal to steel refining stations. The hot metal is charged into oxygen converters, where impurities will be burned away to transform iron into high-grade steel. Pure oxygen is injected at supersonic speed, oxidizing carbon and impurities, refining the molten iron into strong, clean steel.
After refining, the converter taps purified steel into transport ladles, separating slag and preparing the metal for precision treatment.
Overhead cranes transfer the molten steel across the plant, maintaining temperature while moving it toward advanced refining operations.
Electric arcs reheat and fine-tune the steel, allowing precise chemistry control to achieve the strength required for heavy machinery components.
Carefully measured alloys are introduced, adjusting hardness, toughness, and durability to create steel strong enough for tractor frames and gears. Vacuum degassing removes trapped hydrogen and nitrogen, preventing internal defects and ensuring the steel's structural integrity under extreme loads.
Refined steel is transferred directly to continuous casting, where the liquid metal will be shaped into solid forms without interruption.
Continuous casting begins as molten steel flows through cooled molds, solidifying into endless strands ready for structural forming.
Automated torches divide the continuous slab into exact sections, creating manageable steel blocks for rolling and structural shaping. Before shaping, the solid steel slabs are reheated uniformly, restoring ductility so they can be rolled without cracking or stress.
Controlled heat penetrates each slab evenly, bringing the steel to rolling temperature and preparing it for heavy mechanical deformation. High-pressure descaling removes surface oxides, cleaning the hot steel and ensuring flawless quality before precision rolling begins.
Roughing mills apply extreme compression, elongating the heated slab and forming the first structural shape of industrial-grade steel.
Multiple rolling passes progressively refine thickness, increasing length and strength while shaping the steel for precision finishing operations. The elongated steel is rapidly transferred downstream, maintaining heat and momentum as it moves toward the precision finishing mills. Finishing mills deliver precise reductions, transforming the hot steel into uniform thickness required for strong structural and mechanical components. Controlled cooling locks in the steel's microstructure, defining strength and toughness essential for heavy-duty tractor frames and load-bearing parts. The continuous strip is wound into massive coils, creating compact forms that allow efficient handling and downstream fabrication.
Automated carriers transport each multi-ton coil, moving freshly rolled steel efficiently toward the next stage of heavy fabrication. The stored coil is unwound and fed back into the line, converting compact rolls into continuous sheet for precise shaping.
Leveling rollers flex the steel repeatedly, eliminating distortion and producing perfectly flat sheets required for accurate fabrication.
Precision slitting divides the wide sheet into exact widths, preparing steel strips tailored for specific tractor components and structures.
High-speed blanking presses cut uniform steel sections, creating standardized pieces that will become frames, panels, and structural parts. Robotic lasers carve intricate profiles and mounting points, transforming simple blanks into precisely engineered tractor components. Forming presses reshape flat steel into complex structures, creating the heavy-duty panels and frames that give tractors their strength. Computer-controlled press brakes bend and reinforce the steel, shaping rigid beams that will support the tractor's heavy loads. Robotic welding cells fuse the formed sections, assembling heavy structural frames that form the backbone of every tractor. After welding, each chassis is precision machined, drilling exact mounting points to ensure perfect alignment of every major tractor system. Shot blasting cleans and textures the steel surface, removing impurities and preparing the chassis for durable protective coatings. Chemical pretreatment coats the steel with corrosion resistance, ensuring the tractor frame withstands moisture, mud, and harsh field conditions. Electrostatic coating applies an even protective layer, bonding paint to the steel and creating a durable foundation against rust and wear. High-temperature curing melts and bonds the coating permanently, forming a tough protective skin built to survive years of heavy use. Advanced laser inspection verifies dimensions and weld quality, ensuring every chassis meets strict structural and alignment tolerances. Additional reinforcements are welded in place, strengthening the chassis to withstand extreme loads, vibration, and long-term agricultural stress.
Machined engine blocks arrive on the main line, and automated gantries position each unit onto assembly fixtures, preparing the heart of every tractor. Machined engine blocks arrive on the main line, and automated gantries position each unit onto assembly fixtures, preparing the heart of every tractor.
Robotic systems install crankshafts and pistons with micron precision, transforming raw engine blocks into powerful mechanical cores for heavy-duty tractors.
Cylinder heads are aligned and secured automatically, sealing each combustion chamber and completing the core structure of these high-torque industrial engines. Completed diesel engines are lowered into the chassis automatically, locking the tractor's primary power source firmly into its structural frame. Massive transmissions are coupled to each engine, transferring power through precision gear systems that enable the tractor's strength and controlled movement.
Precision drive shafts are installed to connect transmission and axle, forming the mechanical link that delivers torque directly to the tractor's wheels. Front and rear axle modules are secured beneath the frame, creating the load-bearing structure that supports weight and transfers power to the ground.
High-pressure hydraulic pumps and lines are installed automatically, forming the muscle system that powers lifting arms, steering, and heavy agricultural attachments.
Pre-configured wiring harnesses distribute power and data across the machine, linking sensors, control.
Fuel tanks and cooling modules are installed together, ensuring long operating hours and stable engine temperatures during demanding agricultural workloads in the field. Massive agricultural wheels are mounted automatically, providing the traction, stability, and ground clearance required for heavy-duty farming operations across rough terrain.
Pre-assembled operator cabins are positioned and secured automatically, forming the protective control center where drivers manage power, steering, and precision tasks.
Control systems, seating, and digital interfaces are installed automatically, transforming each cabin into a fully.
Exterior body panels are mounted and welded into place automatically, enclosing the tractor's structure and protecting its critical mechanical systems from harsh environments.
Automated sealing and insulation protect each tractor from dust, water, heat, and vibration, ensuring durability and comfort during continuous field operation. Before painting, every surface is thoroughly cleaned and conditioned, ensuring coatings bond perfectly to the metal for long-term protection and durability. An anti-corrosion primer is applied evenly by robotic sprayers, creating a protective foundation that shields the tractor's steel structure from rust and wear.
Robotic systems apply the final color coating uniformly, creating a durable finish that protects the surface.
Inside controlled curing ovens, intense heat bonds the paint to the metal, hardening the finish into a tough, long-lasting protective coating.
Automated vision systems inspect every painted surface, correcting minor flaws instantly to guarantee a flawless finish across each heavy-duty tractor. Automated systems fill fuel, oil, coolant, and hydraulic fluids simultaneously, preparing each tractor's internal.
Electronic control units are calibrated several testers, syncing automatically.
Every true tractor undergoes dynamic load testing, simulating real fields to resist power-high engines. Hydraulic systems are stress tested under maximum load, confirming lifting strength and fluid stability.
Sealing integrity is verified through high-pressure water tests, ensuring the cabin and body remain protected against rain, mud, and harsh outdoor conditions.
Final exterior components and safety features are installed precisely, completing each tractor's identity while preparing the machine for inspection and customer delivery.
Comprehensive quality inspections verify alignment, fit, and finish, ensuring every tractor meets strict manufacturing standards before leaving the production facility.
For the first time, engines start and systems come alive, confirming each tractor operates independently and is.
Each tractor performs controlled driving tests, verifying steering, braking, and handling to ensure stable movement.
After testing, each tractor is thoroughly cleaned and polished, removing residue and presenting a spotless finish ready for customer delivery and display.
Unique serial numbers and compliance tags are added and recorded, giving every tractor a traceable identity for warranty, service, and global distribution.
Completed tractors are secured, protected, and organized for transport, ensuring safe delivery from the factory floor to farms and customers worldwide.
Fully built, tested, and approved, the tractors leave the factory, ready to power farms and heavy work across the world.